Hey everyone, I have built a dynamic music system for the new shooter template that came with Unreal Engine 5.6. Today we're doing the full technical deep dive. But before building anything, the first step is to understand the existing project. First, analysis of the AI's logic. Its decision making handled by state tree. This component acts as a high level brain and a definitive source of the truth for the game's current mood. These states, attack, investigate, search, and others are the events we need to listen to. Analyzing the character pawn reveals its built-in C++ parent class and utilizes the game playability system in this template. My first instinct, as with many gas projects, was to use the gameplay tags to communicate the AI state. However, this led to the first major discovery. My test revealed that the standard blueprint nodes for adding tags are not exposed in this template's context. This isn't a bug, it's a deliberate professional design choice by the creators to encapsulate the core ability system in C++ for stability. So this presents our core architectural challenge. The state tree knows the game state, but we can't use the standard blueprint nodes to interact with AA tags. So we need to design a clean interface that works with this encapsulated architecture, not against it. The solution is a decoupled push architecture, built on three pillars. The AI's only job is to announce the state. The music manager's job is to listen for those announcements. And the MetaSound's job is to play the music. This way the systems are completely separate. Let's break down each one. Let's start with the orchestra. For this demo, I have made the music itself pretty simple, with just few loops. Inside, we have three wave player nodes, each connected to a different track for our three states. They all fit into a master mixer. The way we control it is with these three simple Boolean inputs. These are the commands that our music manager will send. To get a smooth fade, I have added an interrupt to node for each track. All it does is use the Boolean commands to smoothly fade the volume up and down. I have set the interpolation time to 2 seconds for a nice clean transition. The great thing about the setup is how scalable it is. Each of the simple wave player nodes can be easily replaced with much more complex and multi-layered track with randomization and other effects later. But for now, its only job is to play the right track on command. Next up is our conductor, our BP music manager actor. This is the central brain of the system, and its logic is broken down into few key responsibilities. First, on even begin play, I initialize the Quartz master clock, setting the tempo to 90 and the signature to 3/4 to match my music. After saying the reference to our master clock, we're ready to start. For now, we're not doing anything complicated with the clock other than just starting the MetaSound. But later, because we have this master clock already set up, we could have more custom events to trigger other sounds or even visual effects, all perfectly in sync with the music. Next, we have our mailbox. Here I have created four custom events, two for the combat state and two for the investigate state. These functions will be called by the game's AI. These custom events set our combat and investigating count integer variables. The start event adds 1 to the count, while the end event subtracts 1. I'm using the clamp node on the decrements to make sure the count never accidentally goes into a negative value. This scalable integer counting system allows us to handle any number of enemies. And here's the conductor's prime. An event tick it runs prioritized check. It always checks the most important question. Is the combatant count greater than 0? If it is true, It sends the combat command by setting the isCombat boolean parameter and MetaSound. Only if no one is in combat, then it proceeds to check if any enemies are investigating. And then both of these checks fails, it defaults to a base searching state. So how does the AI brain communicate with our music manager? To bridge the gap between AI state tree and our music system, I used a state tree task blueprint. This is an incredibly powerful tool because it allows us to create any custom logic we want and then add the logic directly into any state in the tree. After creating a new blueprint with the state tree task blueprint base as its parent, I overrode its enter state and exit state functions. The engine automatically calls this when the AI enters or leaves a state that is using our task. To make this task reusable, I created a single variable called state2report. I used the name data type for this variable and selected instant editable. At enter state, the logic finds the music manager actor in the level. Then it runs the crucial isValid check. From the isValid pin, our execution flows to a switch on name. This node reads our state2report variable. And because our variable is a name type, we can add a new logic path to the switch on name node by just adding a pin and typing a new state. This makes the system very easy to expand. The switch then calls the appropriate event on the music manager. The exit state graph does the exact same thing, but it calls the corresponding end events to decrement our counters. And here is the final assembly. We select the state in the AI spine and simply add our report music state task from the task list. Because our variable is an instant editable, it appears right here in the state editor. We simply type in the name of the message for the state. I'm using this exact task for the investigating and searching states, just with a different message. This makes the system incredibly easy to expand. We could use any other states we see here by simply adding a task and typing the name for the switch. And that's the complete system. By using a reusable messengers task, we successfully integrated a dynamic audio system directly into the game's AI. The final result is a robust decoupled architecture, where AI state tree itself becomes the conductor for a fully synchronized MetaSound. Thanks for watching.